This is Ms. Black with Open Campus. Believe it or not, we are in Math 102, and we are in Module 18B, our last module to go. And when I last saw you guys, or talked with you guys, we were graphing inequalities, which was similar to graphing equations with some extra steps. So what we're going to do today is we're going to graph a system of inequalities. Remember from our previous modules, systems means we're not graphing one, but we're going to be graphing two or more together. So let's go to look at our class notes. Okay. If you look here, recall a system means two or more. So we're going to be graphing two or more inequalities together. And the solution set of a system is where they would intersect. What's going to happen is because we're graphing inequalities and we're shading, we're going to be looking for the intersection of the shading, and those points will be our solution. So here's our first example. So if you look, this is a system. It's not one inequality, it is two. So I'm asking you to graph two things together, two inequalities together. So we're going to be shading two, and we're going to be looking for the intersection of those shadings. And then we're going to be able to pick a point in that shading to check. So let's go to the whiteboard. We have 4 examples left. Let's go see what we can do. Okay. So we're going to put everything together we have learned. One inequality, two inequalities, hence a system. We want to graph. We go back to basics. Are these linear or nonlinear? I have an x and a y to the first power. This is a linear inequality. It will be a picture of a line. I have an x and a y to the first power. This is a linear inequality. This would be a line. So we're back to what types of lines are these? Horizontal, vertical, or diagonal? They both have an x. They both have a y. So we are obviously graphing diagonal lines. We have already discussed in Module 13, to graph a diagonal line, it has to be in slope-intercept form. What is slope-intercept form? Y equals mx plus b. So we have to isolate y. Well, it's done here. So our m value is 2, the number connected by multiplication, and we write that as a fraction 2 over 1. Our b value, our number behind, is negative 4, and that's our y-intercept. Okay? This inequality is not in slope-intercept form. So to isolate y, we're going to add x. We're going to get negative y is greater than or equal to x minus 1. But we don't want a negative y, so we divide by negative 1. Y, remember we're dividing an inequality by a negative. We reverse the symbol. We get a negative x plus 1. So when you divide by negative 1, it changes all the signs. And with an inequality, it also reverses the symbol. Our number connected by multiplication is negative 1. And as a fraction, it's negative 1 over 1. Our number behind is positive 1. So everybody, that is a review of everything we learned in Module 13. Now, to graph, it doesn't matter which inequality you graph first. We're going to start with this one. I highly suggest you do this in 2 different colored pencils, so it's visual, it sticks out. We're going to begin at negative 4, our y-intercept. We're going to move our slope up 2 to the right 1, up 2 to the right 1. And I would do this several times, seeing we want to see if these lines intersect. You could also reverse directions, go down 2 to the left 1, down 2 to the left 1. Now, here's the new part. It's an inequality. I do not see an equals, so this line cannot be solid. It must be broken. All right, there's our broken line. It is greater than for a diagonal line means to move your hand up. So we would be shading everything up. And I'm going to do it very lightly because we're not done. Now we have a second inequality to graph. So I don't want to shade too dark because I need to still graph another line. We're going to begin at positive 1. And look, I'm doing it in a separate color so it sticks out. My slope is negative 1 over 1, which means down 1 to the right 1, down 1 to the right 1. I could also reverse directions, go up 1 to the left 1. We look, We had an equals, which means this line is solid. All right? We got a solid line. Remember, when you're shading, you always use the equation for the diagonal line and slope-intercept form. So that says less than. So put your pencil on that diagonal line, and less than would be shading down. So in blue, if I shade it down, I'd be shading here. Now, the answer or the solution is where the two shadings intersect. Because that's what we did. Remember when we did the number lines? Greater than, less than, and the shadings intersected? That's what we're doing here. So your solution set is where your two colors intersect, which is in this region right here. So I'm going to put a big SS for solution set. So because these are inequalities, they have an infinite amount of solutions. That's why you can't list them all. That's why we draw a picture. Now, we're going to prove we're right. So down on the bottom of your notes it says pick a point to check. You want to pick a point in your shading. It doesn't matter which point you pick. I'm always going to obviously pick the easiest value possible. So if I look very closely at my shading, where the blue and the red intersect, 0, 0, the origin is in there. So I'm going to choose that as my point to pick. So I am picking to check 0, 0. If this region is truly the solution set, then this point should make both of these inequalities true statements. So let's do our substituting. Y is 0, greater than 2, x is 0, minus 4. We are not finished with the check till we get the balance. 0 is greater than. 2 times 0 is 0. 0 minus 4 is negative 4. Is 0 greater than negative 4? Sure is. It checks. But that doesn't mean it's the solution. Remember when we did systems, to be a solution, it's got to check in both. So now we're going to check here. We have negative x is 0, minus y is 0, greater than or equal to negative 1. There is no such thing as negative 0. This is just 0 minus 0, which is 0. Is 0 greater than or equal to negative 1? It sure is. It checks in both. You could have picked any point in that shaded region where the both shadings overlap. Always look for the most obvious point to pick, the easiest. And because the origin was in there, that's the easiest to check. Okay, so far so good. Let's try another system. Okay, so let's look at our notes. Let's step it up a notch. We want to check x plus 2 squared plus y minus 1 squared is less than 1. And the other inequality is y is greater than or equal to negative x minus 1. So you guys look at that a minute and make a decision, first of all, if they're linear or not linear, and then what the heck are you graphing? Well, I cleaned the whiteboard. I'm going to let you think. All right. So if you look at the first inequality there, it has an x squared and a y squared. So obviously it is not linear. If you have a square and a square, x squared is a curve, y squared is a curve, the plus brings the two curves together. So it's either got to be a circle or an ellipse. How do you decide if it's a circle or an ellipse? You look at the denominators. Well, the invisible denominator is 1. The invisible denominator is 1. If the denominators are the same, you're moving the same distance. Hence, you have a circle. If you know your rules, you should have memorized for a circle. We're going to write it on the board. X minus h squared plus y minus k squared equals r squared. Our inequality is in that form. We know it's a circle. What are the ingredients you need to graph a circle? You need the center and the radius. The center is h and k. H is the opposite, negative 2. K is the opposite, positive 1. The radius is whatever this number is if you square root it, because it stands for r squared. So the square root of 1 is 1. And it's only positive because a radius is a distance, and a distance must be positive. So we're going to graph that circle. We also have to graph this inequality. Well, if we look closely at that, it's linear. Y to the first power, x to the first power. It's a line. It has an x and a y. It's a diagonal line. So is it in slope-intercept form? It sure is. So what's our number connected by multiplication? It's -1 over 1. What's our number behind? -1. It does not matter when you go to graph the inequality which inequality you graph first. It's up to you. So I do not care if you graph the circle first or the line first. So let me just clean this up a little bit. All right. Let's graph the circle first. So the center is -2, 1. And this is going to be a baby circle because the radius is only moving 1. 1 up, 1 down, 1 right, 1 left. It's a little circle. Because there is no equals, the circle's got to be broken. And we talked about this. Less than for a circle means to shade the inside. All right? So that's done. Now we're going to graph the line. We have the slope and the y-intercept. We're going to begin at -1, the y-intercept. Our slope is -1 over 1, which means we move down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. We can move backwards, up 1 to the left 1, up 1 to the left 1, and so on. All righty? I do have an equals on my inequality, so this line is solid. And yes, this line is going right through the circle. The shading greater than means to always shade up on a diagonal line. So if you take your diagonal line and you shade up, that's what you're shading, all of that. The solution set is where the shadings intersect. So it's not just what's in green, it's not just what's in yellow, it's right here where the green and yellow intersect. So you could put a big SS right in this little section here, or what they usually like you to do if you look in your college book is they will erase all this shading and only have shaded the part where the intersection is. So a lot of times in the textbook, they will only have shaded where the intersection is. Again, because we're visual learners, we have to graph both and figure out the intersections right here. So that's why I'm putting in SS. It's in this little sliver right here. Now, I want you to check a point to prove it. So let me erase this work so we can check a point. Now, 9 times out of 10, when we check a point, it's inside where the shading is. Well, if you look inside here, it's very hard to find a point that's a whole number. Anything inside the yellow is not on a corner. So sometimes, if you can't find a point inside the shading, you have to look around the edges of the shading. But here's the problem. If you follow the edges of the shading, it's this part of the circle with this line. You cannot use this point or this point because it's on a broken part, which means it's not part of the solution. What you can use is use this point, which is on the line. Because the line is solid, we can use that as a point. That is the solution. And this point is at -2, 1. So sometimes the point that you check is not physically inside the shaded region. It's around the edge of the shaded region. Remember, if it's around the edge, it has to be on a solid line or curve. Because if it's solid, it's part of the solution. So now we're going to check it in both. So we're going to write x is -2. Y is 1. And then we're going to do our arithmetic. -2 plus 2 is 0. 1 minus 1 is 0. 0 squared is 0. 0 squared is 0. If you add 0, you get 0. Is 0 less than 1? It checks. But it's got to check in both to truly be the solution. So now we're going to check -2, 1. y is 1. Bring down the negative. X is negative 2. That's where y'all make your boo-boo. You forget to bring down that negative. Then the x is negative 2. Well, you're right. 2 negatives side by side make a positive. 2 minus 1 is 1. Is 1 greater than or equal to 1? It's not greater than, but or means one or the other, so it is equal to 1. It checks in both, which means you did shade the correct region. Is everybody okay? Great. Let's look at our third set. Okay. Our third set of inequalities we want to graph. All right? We have x squared plus y squared is less than or equal to 1. X plus y is greater than 6. So I'm going to give you all a minute to look at that and make a decision. It's the same decisions we've been making now. We look at an inequality. We look at an equation. We first decide if they're linear or not linear. So everybody look closely at the first one. Is that inequality, x squared plus y squared, less than or equal to 1, linear or not linear? Good. It's not linear. You have an x squared and a y squared, which means it can't be a line. And if it's not a line, it's a curve. And we've discussed this over and over. X squared's a curve. Y squared's a curve. The plus brings the two curves together. So it's either a circle or an ellipse. You do not see denominators, so they're invisible ones. If the denominators are the same, it's a circle. We have memorized over and over again. X minus h squared plus y minus k squared equals r squared is the equation of a circle in standard form, ready to graph. Okay. I don't see anything being subtracted to the x, so it's an invisible 0. I don't see any number being subtracted from the y, so it's an invisible 0. So there's the equation written in the correct form. So now we can see the center is the origin, 0, 0. The radius is the square root of this number, and the square root of 1 is 1. So again, there's going to be an itty-bitty circle. We're going to plot the center at the origin. We're going to move up 1, down 1, right 1, left 1. It has an equals, which means we can make that circle solid. It has a less than, which means we would shade the inside. Okay? So I'm going to get a light marker just to shade the inside. All right. The next inequality is x plus y is greater than 6. Well, that's linear. X to the first, y to the first. Linear means line. If it has an x and a y, it's a diagonal line. If it's a diagonal line, what form does it got to be in? Correct, slope-intercept. So we get y by itself. We get y is greater than negative x plus 6. What's my number being connected by multiplication? It's negative 1 over 1. What's my number behind? 6. So in a different color, we're going to go to the y-axis to 6. We are going to move down 1 to the right 1. I'm doing that. All right. I do not see an equals, so that means our line has got to be broken. These points are not part of the solution. It has greater than. I put my pencil down. Shading a diagonal line is always up. Greater than shades up. Well, what you will notice is, because we're graphing a system, the purpose is the shadings should intersect. We should be looking for what they have in common, because that would be the points that are the solution to both. Do you see your shadings intersecting? No. Here's your yellow. Here's all the points that work for the circle. In green are here all the points that work for the diagonal line. There is no intersection. So that means there's no point, there is no x and y value you could put here and put here that will make both of these statements true. Therefore, there is no solution. Wow, does that ring a bell? There's your symbol. So it's okay when you're graphing a system to realize if the shadings do not intersect, there is not a point they have in common that will make both statements true. Therefore, there can be no solution. Good? Awesome. All right, believe it or not, we have made it now to the end. This is the last example I'm going to work with you guys and gals. Okay, and we're going to, again, go over our basics. All right, so let's get to our last example. All right, we are given the inequality. Y is less than or equal to x minus 2. We are given the inequality. Y is greater than or equal to x squared minus 4. All righty, here we go. Last one. Linear or not linear? X to the first power, y to the first power. Linear. Linear means line. Which line is it? Horizontal, vertical, or diagonal? Very good. It's diagonal. It has an x and a y. Is it in slope-intercept form? Yes, it is. So what's the number connected by multiplication to the x? It's 1 over 1. What's the number behind x? Negative 2. Great. We can go graph that right now. Let's go to the y-intercept, negative 2. Let's move up 1 to the right 1. Do we make our line solid or broken? I see an equals. This is solid. Any of these points are part of the solution. With a light color, which way are we going to shade? It's a less than. Put your pencil on the diagonal line, and less than means move your pencil down. So we're shading all here. All right. These are all the points that would make this statement true. All right, here we go. Start the process over. Linear or not linear? Not linear. I have an x squared. If only the x is squared, what kind of inequality is this? It is quadratic. Quadratics are pictures of parabolas. Okay. What information do we need to graph a parabola? Well, first of all, we need to know it's got to be in the form y equals a x minus h squared plus k. Yes, these are memorized facts you have learned through the semester. All right, let's make sure it's in the right form. I got the y by itself. It's greater than or equal to. A is always connected to x squared by multiplication. That's 1. I have x minus. Is there a number being subtracted from the x before you get to the square? No. So it must be invisible 0. The k is the number at the back. It's negative 4. So that equation is ready to graph. When your equation of your parabola is in this form, we know the vertex point. So the vertex point is 0, negative 4. Remember, what's inside becomes the opposite. Well, there is no opposite to 0. What's outside here, k, stays the same. We also know, because the a value is 1, if it's positive, the parabola turns up. Well, we know if we plot 0, negative 4, and it turns up, we don't have enough information. We know by it turning up, it's going to touch the x-axis. So now we got to go find the x-intercepts. So we talked about this. Parabolas require more work, because besides plotting the vertex point, you got to know the intercepts. This point is already on the y-axis, so we already know the y-intercept. So we got to get the x-intercepts. To find x, we let y be 0. So we go back up here. We're going to let y be 0. We don't want to say greater than or equal to, because if you're on the x-axis, you equal 0. So y equals x squared minus 4. You have a quadratic equation. I do not care which of the 4 methods you use to solve that. If you want to do the quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Go for it. If you want to do complete the square, go for it. Out of the 4 methods we learned to solve a quadratic, the 2 quickest is either factoring or square rooting. I'm a fan of square rooting. Move the constant over. Square root both sides. Squares and square roots cancel out. That's where the x comes from. I know the square root of 4 is 2. Because you did the square root method, you have to put both plus or minus. That means there's 2 x-intercepts. One x-intercept is at 2, 0, because that's what y is. The other one's at negative 2, 0. So now I can go plot that. 2, 0, negative 2, 0. I have 3 points. So I have enough to make the parabola, the u. I have an equals, which means the parabola is solid. I have a greater than. Greater than for the parabola means to shade the inside. So let me get a different color. And if I shade the inside. So let's look again. The diagonal line is shaded all down here, right? There's the diagonal line, everything down there. Now I'm going to shade the inside of the parabola. Can you see where the shadings overlapped? This is all in orange, so that's not the answer. All this on the outside here is yellow. That's not the answer. The shadings overlapped right in here. This is the solution set. So when you look in a textbook, they'll only have shading in this region. When you're doing it by hand, because you're shading both, put an SS in here to say that this is the solution set. Now, to finish it up, let's prove you are correct. So what you have to do is you have to pick a point in the solution set. What I want everybody to look closely at is the origin in the solution set. No, so you can't pick that. Don't assume you always check the origin. You check a point in the solution set. So look, there's quite a few points in here you could check. This points out a whole number. That's 1, negative 2. This points out a whole number. 0, negative 3. Okay? Pick whatever you like, but pick a whole number. I'm going to pick this point. 0, negative 3. And let's see. Replace y with negative 3. Replace x with 0. Do my substitution. Let's do my arithmetic. 0 minus 2 is negative 2. Is negative 3 less than or equal to negative 2? Sure is. Let's go over here. Y is negative 3. Greater than or equal to? X is 0. That's a negative 3. 0 squared is 0. 0 minus 4 is negative 4. Is negative 3 greater than or equal to negative 4? It sure is. So ladies and gentlemen, you have now completed the last module for college algebra. I hope that now that we're done, you have got a better understanding of how algebra works. I hope that you understand how algebra relates to everything you learn in arithmetic. I hope that you've made a connection, that every equation we learned how to solve on paper, you can draw a picture of, and it becomes a graph. I very much enjoyed doing all these lessons with you. I hope you find some success in college algebra. Thank you.